Hello, I'm Chris from Intelli-plan Software Limited, and I'm here today to show you how simple it is to use our product, Aliquis. Aliquis is a generic process modeler. Therefore, it can be utilized to model any type of activity. Now, to illustrate my point, and for a little bit of fun in the process, let us model the operations included in making a cup of tea for, let's say, your significant other. As we know, the first thing you have to do when you make a cup of tea is boil the kettle. As we do not precisely measure the amount of water we put in, we therefore cannot accurately predict the time it will take to bring the kettle to boil. With Aliquis, we can represent this uncertainty through what is known as an uncertain delay block. So, as you can see on the screen, I'm just dropping one of these delay blocks into our process modeler. And I can set the name to boil kettle and give it a minimum delay of, let's say, around 60 seconds. I can also give it a maximum delay of 120 seconds to represent the uncertainty in this process. The next task in our process is to warm the pot, which in practice takes the form of pouring the boiling water into the pot. As with the last block, I will give it the name warm pot, and I'll give it a time of maybe 30 seconds. The tea will then brew for between 2 and 3 minutes, and I'll name this block brew, setting the minimum time to 120 seconds, representing the 2 minutes, and the maximum time to 180 seconds, representing the 3 minutes. Now, as we all want to impress our partners, we will now make up the tea tray, which involves various jobs, but for simplicity's sake, we will collapse them all into one block, calling the block makeup tray. And we will give this block a delay of 30 seconds as we had with the warm pot block. We will now deliver the tea, giving the block the name deliver, and we will estimate that the time taken to do this will be between 30 and 60 seconds. Now at this point, we need to notice that there is an element of risk in our process, as I could spill the tray going up the stairs, or something like that, meaning that there is a significant delay in the arrival of the tea. To build this potential problem into our model, we're going to insert a divert block. Now this divert block steers the path of the processes to the failure port, which makes the process reset. The probability for this failure is set by the prob_fail parameter, which in this case is 0.1. We are now going to start solving the model. Initially, we will just step through in time steps. As a product, Aliquis doesn't have fixed times, but instead creates a time for every set it takes. So let's just run it again. As you may have noticed, every time you do a solve, you get a different answer for your model. To track all these different results, what we're going to do is record the finish time for each solve and run the simulation many times. A couple of thousand should do the trick. In the business, this is known as a Monte Carlo simulation. We're now going to go and get a histogram of our recorded solves. And as you can see, there is a general time of around 300 seconds for all the processes. But every so often, the process fails due to me spilling it. And sometimes I've spilt it twice, and in one case even 3 times. What a nightmare that was. Aliquis. Simple to use and yet powerful.